there. The next section I want to cover now is power protection. So why do we have power protection? Well, you could imagine a server, and this occurs at school as well. If there is a slight fluctuation in the delivery of power to any computer, it'll cause it to restart. It'll just turn off and on. And when you turn a computer off at the power point, it has a whole heap of files that are open. And when you shut a computer down, it just closes off all those files. And you can actually damage a computer's operating system by just yanking the plug out of the wall. And this is what happens if there's a power failure. And it doesn't have to be like 20 minutes. It can be like a fraction of a second. And it will cause a server to restart. And that can upset your system and corrupt your data. So what we have are things called surge protectors. Now, a surge protector is like a large battery that will keep the power to a computer for, say, 20 minutes. And they can also be programmed to shut down the computer properly so it doesn't damage the data. All right, so say, just a minor fluctuation in power, they can manage that quite easily without shutting everything down. They can just keep the computer going for that fraction of a second. That's not such a big deal. But not a surge protector, but an uninterruptible power supply, what we call a UPS, will keep that computer going. And if it's realising it's running out of battery power, it will shut the machine down. Okay, so in our server room at school, we have a number of UPSs that keep our servers going in the event that there is a power failure. Now, a surge protector, what it does, it just protects computer equipment from those surges of electricity, such as when lightning strikes, you can get this massive voltage run through your system, and a surge protector will take that surge out, and so it won't damage any of the components or anything like that. So we now look at some strategies for avoiding system failure. So system failures occur when there's some fault in an important item of equipment in the system. This could be a power supply, CPU, hard disk, or even RAM. That's the random access memory that, when a computer boots up, the operating system goes to that memory. There's two main safeguards against system failure. It's redundancy, what we call redundancy through multiple hard drives or fault-tolerated equipment, and redundancy through mirrored servers or machines. So redundancy means no single part of the system is critical to its overall operation. Okay, if one part fails, the others, in this case hard drives, mirrored machines, can take over its job and keep the system running until the part is replaced. These systems are called fault-tolerated systems. The failure of a hard drive with all of a company's critical data would be a disaster. It's often been reported by ZNet that if a stock exchange server had to be rebooted, it would cost the US $100 million to recover lost data. Backups might help restore the data, but this will take valuable time. A common solution to continuously copy data onto a second mirrored hard drive is the way to go. If the main drive fails, then a duplicate set of data is available on the mirrored drive. So, what we have is a system constantly backing itself up in real time, all the time. But a more popular method of guarding against hard disk failure is to use a redundant array of inexpensive disks, which is called RAID, R-A-I-D. You have a RAID array. And a RAID is normally used on a computer network. In these systems, fragments of data are spread over several hard drives, so that if one hard drive fails, the others can piece together the missing data and rebuild the file using error-checking codes. A user will not know if one of the RAID disks has failed because the data is fixed rapidly. It's important that a damaged disk is replaced soon after, as the failure of another disk could make the repair of files too difficult. So imagine this. You have a server that needs to be going 24 hours a day, non-stop. One of the hard drives in its RAID array fails and ceases to work. So what a technician would do in that case is, while everything is continuing because the other 4 or 5 disks in the array have corrected the problem, and so it's not relying on that broken down disk anymore. The technician doesn't have to shut the server down. They merely pull the drive out and put another one in straight away. Okay, so these servers are configured so you can just take a hard drive out of the sleeve that it sits in, and then another one goes straight in. When the other one goes straight in, the data and information is then built over all of the drives. Okay, so that's how a RAID array works. It's for that problem. If 1 or 2 fails, the others can continue. They also back up as well, of course, but this is one way of maintaining service. So where there is a possibility of any other critical component of a computer failing, an entire mirrored computer or server may be used. All the data is saved to both machines, so that if the primary machine fails, files are accessed from the second machine instead. So as I mentioned earlier about the stock exchange, if one of their machines went down, they only had to reboot it. It would cost $100 million. And, companies cannot afford their servers to go down at any time, particularly financial companies like insurance companies, banks, all those sorts of companies. So now we're going to look at backup media. As little as 10 years ago, not long ago, there were still very few options in how you backed up your media. Either you ran the risk of operating without a backup, or you spent a great deal of money and bought what we call a tape drive. Okay, so 10 years ago, we didn't have these massive drives that we've got. So you can buy a terabyte drive now very cheaply. But 10 years ago, the maximum drive that you could buy was about a couple of gigs. It wasn't very big at all. Businesses used to back up their information onto CDs or DVDs, and if they could afford it, they'd buy a tape drive. Personal computer owners used to make backups of their data onto CDs. Now there's a wide range of different types of backup devices from which to choose, and demand has driven down the prices of these devices. The choice of software is quite important. Windows has a backup and restore utility. Several other software manufacturers produce backup software, which include Norton, Amiga, and Computer Associates. These days, of course, this text was written, 5, 6 years ago. Now you can buy backup drives with software built into them, so you just plug them into your machine and they automatically back up what's on the machine. Apple, for example, has Time Machine software as part of their operating system. So you can plug a drive in, an external drive into your machine, and it'll back up everything straight away. Okay, so if you're using small backups, you can use file management utilities such as Windows Explorer to simply copy files across onto a backup device. Oh, that's fairly straightforward. You just nominate, your home directory and drag it across to your disk and back it up. A lot of people back it up onto USBs, but USB devices are notoriously inconsistent in their reliability, so I'll be very careful when you back up to a USB. Backup programs can either perform a simple copy of files or they can compress files to save space. The second option requires you to have a backup program installed on any computer. Backup programs can also allow files to span multiple storage devices if they're too large to fit on one. So we don't particularly worry about the cost of backup these days. We look at, even a very cheap drive will give us at least 500 gigabytes, which is quite okay for most backups these days. So on page 290 we have an illustration here of a pyramid showing the relationship between cost and speed. The less expensive type of backup medium is a tape drive, and when you use a tape drive you just put it in your computer, little tape, and leave it going all night and it'll back up all night. The more expensive and more faster backup mediums include hard disks, solid state drives and memory. There are three categories of backup media: magnetic media, optical drives and solid state drives. Now, magnetic media comes down to hard drives which have platters in them that spin. Okay, so that's the affordable option, and for a long time I had one of these devices I could just drop a hard drive into and use that as my backup. When that got full I could just pull that drive out, get another one and just put it in. So some people use those to back up onto, and they're quite good. In some cases users may back up to a networked hard drive located off-site. When we look at backing up protocols and policies, it's always a good idea to have a number of backup places you can back up on site, and if the building that you're in burns down or gets flooded or something, it's always a good idea to have a backup off-site somewhere, more secure. Magnetic tapes are pretty popular, but I think they're sort of falling away in popularity now. They're relatively cheap, but they're very slow to save and restore files. So the tape has to be accessed what we call sequentially. So you've got to run the tape through to the bit which has got the file so you can restore it. Where the time required to complete a backup is not the issue, such as when the backup can be performed overnight, a tape can provide a cheaper and larger capacity storage option than a CD or a DVD. Many organisations have automated tape drives connected to their network servers so that all the data can back up overnight. See how old this book is? A CD or a DVD has got 4.5 gigs maximum space, right? You can buy a 16 gig USB key, and if you get a really good one that's secure, that's got tons more space, and if you use USB 3 connectors, that'll store the material up very quickly. The next sort of backup media is optical media, which is your compact disc, DVDs and even Blu-rays, although Blu-ray has fallen out of popularity these days. So Blu-ray disc format has a capacity of up to 50 gigabytes, but a small solid state drive, which is quite cheap now, has way more savable space than a Blu-ray, and a lot quicker to save to. So now we have solid state drives, which is USB devices. Okay, USB flash drives can hold up to 256 gigabytes of data and come in a variety of devices, ranging from single purpose to multi-purpose device incorporating MP3 players, watches and novelty devices. Since this book has been printed, we now have solid state hard drives. For example, you'll notice that the computers in A2 now start up a lot quicker because we've just taken out all the old hard drives and replaced them with 160 gig solid state drives. So they solid state drives read and push out the data to the CPU a lot quicker. That's why it boots up really quick now. So now we look at online backups. And this has become more popular today, is an online backup. So the reason being that data online bandwidth has become quite cheap these days. I mean, most internet connections now come with a really generous bandwidth of usage. 500 gigs a month is not uncommon. Unlimited is not uncommon either. So the way in which online backups work is that every time you log in, you upload any files to a website, such as there's a number of them. Carbonite, I know, is one of them. $60 a month, maybe a bit more, maybe $70 a month. It will back up your entire computer. Now, your entire computer may hold, let's say, 300 gigs of information and programs. You might elect to say, I'll only back up my data, which could be 100 gigs of, say, music and files, programs, whatever. It'll take a while to process all of that, but once it's all up there, every time you change a file on your computer, it will back it up. So if you need to retrieve a file that you've lost, or maybe your computer breaks down, you lose your hard drive, then you can restore it all back from your online repository.